Hello everyone, very good morning. Welcome to the new sessions of Docker, Kubernetes and Terraform. Or else I can simply say that uh, infrastructure as a code with containerization and orchestration. So today we will be having this pretty similar or else pretty simple demo, or I can call it as a lecture on these three topics. Now, before we diving into the concepts, like Uh, we will be going into Terraform. We will be discussing about the Docker. We will be discussing about the containerization. These are all the concepts that we are going to discuss. Okay. Now, what is this Docker? What is this container? What is this Kubernetes? And what is Terraform? Why we exactly need Terraform? Majority number of the companies. Okay. So if you go for an interview, okay, for an interview on DevOps. Now everyone are asking for a majorly three tools, the most important tools, that is Terraform, Docker, and Kubernetes. Okay. Before I discuss about all these topics, let me introduce about myself. Hello everyone, I am Chaitanya. I will be your trainer for the next 1 month, like 30 days. And in this sessions, I have an experience into the DevOps, and currently I'm working as a DevSecOps engineer. From 2013 onwards, I'm training the candidates on the like what I can say server. Okay, Microsoft Server 2008, 2011, 2016, and then I have changed my path to the cloud environment. There I have trained the students on AWS, DevOps, Kubernetes. Okay. So if you ask me the certifications, what I have done, I'm a Microsoft certified, I'm a Red Hat certified, and I'm having my certifications in AWS, and I'm a certified Kubernetes administrator. These are the certifications which I have. And currently I'm working as a DevSecOps engineer, level 5, and I am in the research and development wing. So these are my achievements, and from past 12 to 13 years onwards, I'm training the candidates on this on multiple environments, okay, on multiple domains. So that is about my introduction. So now, when we are talking about the DevOps, so now what is DevOps and what are these tools, Terraform, Docker, and Kubernetes, what they are going to do? Let us see. Before I go into the topic, let me ask you a small question. Can you please introduce about yourself so that I can have a clarity about who are my audience or else who are my friends? Yeah, anyone? Can you please unmute yourself and introduce about yourself?
Hello.
Yeah. Hi, Pramod.
Um, Hi. I'm a master student. I'm currently looking for opportunities in DevOps, DevSecOps with AI or something like that.
Masters in.
Software engineering.
Okay. So you're looking after the opportunities in DevOps. Okay. Fine.
Yes.
Hmm.
I already completed a course in some other coaching institute. I have some idea on the topics, but I felt like I need some more deeper understanding. So I joined this course
Mhm.
specifically for that.
Okay. Fine. We'll discuss about what we are going to discuss.
Okay.
Yeah. Any another person?
Hello.
Yeah. Hi.
Hi, I'm Amit.
Yeah.
Uh,
Hi.
I have an experience of around 10 years. I wanted to specifically, learn about Terraform and Kubernetes.
10 years into.
So, 10 years into multiple tech. So, I have worked primarily the application developer for around 7 years. Worked as a um, cloud engineer for next 2.5 to 3 years.
Okay. On which cloud you have worked on?
Primarily GCP.
GCP. Okay. Do you have any idea about AWS?
Yes, I have. I have worked on some of the services, but
Mhm.
experience has been around, morely on GCP.
Okay, fine. No problem. Hmm. Thank you. Thank you, Amit. Any another people want to introduce about themselves? Okay, fine.
Yeah, Ben, your AWS student, wants to
Yeah,
learn
hi, Ben.
more.
Mhm.
Yeah, wants to learn more Terraform.
Okay, fine.
Yeah.
Cool.
Thank you.
Right, guys. So we'll go through the first of all. Let me start this technical concept, and we'll discuss about what and what, and then we will go ahead into the concept of understanding Terraform, Docker, and Kubernetes. Just a brief introduction. And from tomorrow onwards, we'll start with the Docker containerization and then Kubernetes, and finally we'll discuss about the Terraform if there is any possibility, or else we will start with Terraform and then we will go ahead with Docker and finally with the Kubernetes. Any which ways, alternative. So either this the first or the Terraform will be the last. Okay, we'll see related to the depending on the number of candidates and all the things. We'll discuss about that topic. Okay. So now let us go through the introduction of Terraform. Now, what is this Terraform and why we need to have this in the DevOps? So, what is this DevOps? So, everyone, whenever we are talking about the DevOps, so everyone will say that it's a developer operation, and there is the combination of development team, operations team combined together to create the automation, or else to create the application with a simpler and having the multiple automation steps. So, but actually, DevOps is a methodology where we are going to provide the application, like end-to-end application with all the automation techniques and CI/CD pipelining included into that, and I mean, whenever you want to create an application within a simple steps, you can create the application. You don't need to worry about that. So once the developer has updated the code into the GitHub repository, automatically the versions will be built, and then automatically it is going to deploy, and finally it is going to give you the output into the production environment. So that is how the DevOps has built. So in DevOps, we are having three main things. One is the automation. Automation in the sense streamlining the process to enhance the efficiency and reducing the errors. So with the help of shell scripting or else Python scripting, we can automate the entire process. So understanding the requirements and what to do. So we can write a shell script or else we can write a Python script depending on that whenever. So what happens actually here? Okay, so let us understand in an story manner. Okay, for example, there is a very small non-IT company is there. For example, there is a travel agency is there. And this travel agency, and I'm just talking about a travel agency. This travel agency doesn't know how to provide the application for their customers. So there are lots and lots of customers who are very, very interested in travel. And this travel agency is the key for all the customers, like it is providing the offers and everything. So now everyone I mean, those who are most number of the customers want to go to some tours and travels with this travel agency. So it's a non-IT company. Though they don't know how to develop the web applications or else the mobile applications. They don't know about that. So now what they are going to do here is they will approach the nearest IT support. So IT support in the sense they will approach to the nearest IT company. So when they approach to the nearest IT company, so this like if you see a red bus, so for us it will be like a very small application which will be helpful for booking the train tickets, bus tickets, flight tickets. But for that also, it need a lots and lots of applications and integration of lots of software development is required. So for that, what that particular company is going to do? It is going to tie up with the IT company and request an application for their customers. So now what this IT company will do? IT company will have a meeting with the development team. So who are the primary key developers are there? They will have the meeting with this development team, and this development team will understand the requirements, will gather the requirements from the client. Okay, what are your requirements? What is your primary logo? How you want the color grading, and how many microservices that we will be having. So microservices in the sense, for example, let us take Redbus. So in Redbus, we are having, when we click on the bus icon, so it will be taking us to that particular microservice, bus microservice. Train icon, it will be taking us to the that particular IRCTC or else that particular microservice. When I click on flight microservice, it will take us to my plane tickets booking my website. And when I click on hotels, it is routing me to the hotels microservice. Like that, there are so many microservices, and as well as internally, you will have the payment microservice, notification microservice. Once you have, so if you try to book a bus, you will put the from and to, which means source and destination, and you will select a bus, and then you will go to the process the payment. And once the payment is done, then it has to go for the notification. You need to get a notification, and finally, then there will be itinerary service, or else what I will call it as not itinerary. There will be inside the database, it has to update that this particular seat has been filled. So all these things has to be done. So for each and every task, there is a microservice. So now what developer will do here is developer will understand the requirement. So whatever that particular application needs, he or else the team will understand the requirement, and they will try to design the application. So there will be front end developers. They are called as UI developers, user interface developers. Okay, so whatever the front end that you are seeing on the browser. Okay, so that is the front end application which you are seeing over here. And there will be what I can say, there will be backend applications will be there. Backend applications will be developed with the help of your what I can say, Java, Python, or else .NET. So such kind of applications will be used to develop these backend applications. Okay, Python and .NET. So the UI will be integrated to the backend, and from the backend there will be databases connected. So depending like this, what they are going to do, they are going to analyze the entire application architecture, and they will start doing that. So here you can see the SDLC will be included. SDLC in the sense software development lifecycle. The first one is requirement gathering, so which we have done from the client, and then the designing process. So how the application should be, what are the different microservices should be there, and what is the database that we have to use. Everything will be comes under the designing, and then the implementation process, implementation in the sense creating the code, building the application, that will completely come under the implementation process. Now at the time of implementing the application, there comes the infrastructure, the operations team. So what this operations team has to do here is they have to create the, first of all, they need to create the databases. So here it is like not from front end to back end, or else front end to the databases. Here it will be like databases to the front end. So first they need to create the database. Inside the database, they need to put a schema. Like for example, MySQL database is there. MySQL database, it's an RDS. So you have to create a table. So these are all the database management system and DBA, database administration. They will be looking after that. There are certain employees who will be looking after the databases. So DevOps engineer don't need to involve into that. If you involve into that, that's a separate post that you are going to get. But as of now, so that is called as SRE. So you are going to get an post of SRE, site reliability engineer. So the site reliability engineer should have the knowledge on DevOps and databases and creating the databases, everything he should have a clear cut understanding. But anyways, coming back to our point here. So first thing what you are going to do here is you are going to create a server. Whenever you want to create a server, how this DevOps engineer or else how this person or else how this operations team will create the server. So to create the server, first and the foremost thing what they require here is, first of all, they have to contact the nearest OEM. So first of all, they have to contact to the nearest OEM. So what is OEM means? Original Equipment Management or else manager. Original equipment manager in the sense, for example, you want to purchase the Dell server. If you want to purchase the Dell server, so you have to contact to the that particular Dell. What I can say, you will be going nearest to whoever are the nearest vendor is there. You will go to that nearest vendor, Dell vendor. So he won't have the servers. First of all, he needs to gather the requirements from you, and he has to submit it to the Dell company, and Dell company has to send the server for you. So first of all, you need to get the quotation, and after getting the quotation, you need to submit it to the financial department. Financial department has to provide the approval for you, and finally, you have to submit that quotation for the OEM, and the OEM has to approve that. Once it is approving that, then finally you have to release. You need to have an SLA. Okay, so this much amount I will pay in the beginning. Once I got the equipment, I will pay the rest of the amount. So some 25% amount you have to pay, and 75% of the amount you will pay after you get the equipment. So like this process will happen. So why? Because I have worked under this process, I am telling you. So to complete this process, it is going to take you some 25 days, or else depending on the OEM and depending on the availability of your server, 2 to 25 days. It is 2 weeks to 25 days. It is going to take, and you are going to get your server. So it is a huge long process. So once you got the server, then what is going to happen? You cannot directly uh, you cannot directly put the server into the network. First of all, you have to do the server hardening. Server security will be the server hardening you have to do. And quotation is not nothing. Quotation is not mail. Quotation is about the pricing. Okay, so the what are the infrastructure, what is the server requirements, CPU, RAM, and storage, how much amount it will be having per CPU, what is the price, which CPU we are going to use, which RAM that we are going to use, how much amount of RAM will be there for each amount. For example, I want to have 256 GB of RAM or 512 GB of RAM for a server. Then what is the cost of that particular RAM? I'm talking about the RAM only. I'm not talking about the hard disk here. RAM, 512 GB of RAM. Some servers will be having TBs of RAM also. Depending on your requirement, how you are going to purchase, how you are going to get that equipment, you are going to get the quotation. Once you got the quotation, it will take some weeks of time to gather the equipment. Once you got the equipment, it is going to take lots of time again for connecting that equipment to the server, that particular server to the network. First of all, you have to do the server hardening. Server hardening in the sense, is there any malicious attack is happened on the server, or it might be a brand new server. So first of all, we have to be very careful before we are connecting the server to the network, and later installing the operating system. And then after installing the operating system, we have to check out the everything, and later we need to install the application. So first of all, we need to connect the databases, and then we have to create the application, and then we have to create the front end. So this will all take some 2 to 3 months to complete the entire process. So if you purchase a single server, so just assume that. So for purchasing a server, it is going to take this much amount of time, and then installing the applications, installing the software, and running the application, and finally, so implementation is done. Implementation in the sense running the application inside a server. So implementation phase is completed. And after implementation phase, again the testing team has to test the application. What are the bugs that are there inside the application? Whether the application is running fine or not. If it is running fine, what I can say, uh, functionalities that is given to each and every segment, whether the functionalities are working fine or not. If the user click on sign in, it should not go to sign up. Okay, there is a difference between login and sign up. So login means already the user is registered and he has to log in into his account. But when he clicks on the login, it should not go to the register page or sign up page. So these are the functionalities. So every phase functionalities has to be looked after. And finally, the testing will be done. Once the testing is done, then we should go to the staging. Staging means so the testing, whatever is done here, that is done by the IT company, and then you have to go for the user acceptance testing. Whatever the application developed by the developers is the same application that is the client requirement. For example, I want the red bus application. Somebody cannot give the Abibus application, no. So whatever the application that is required by the client, the same application, whether we have designed or not. So user has to accept it. User has to understand each and every functionality. User has to again test it. So that is what we call it as UAT, user acceptance testing. And finally, when the user is satisfied with the product, then it will be going into the user in the sense client. Then it will be going into the production environment. Again, in the production environment, we need to have the servers. We need to have a discussion with the client saying that whether you will have the servers or else we need to procure the servers, which means that do I need to get the production servers? Most of the cases, the client will have his own servers. The IT team will not be responsible for the production environment. Why? Because the client will have his own production environment. He should have that. Otherwise, we can create our production environment when he gives us the confirmation. Once the application is into the production and everyone are using right now, whatever the applications that you are using either through your mobile or else through the internet, those are all in the production environment. There comes the main picture called as maintenance. So what is this maintenance? Monitoring the application. There are any sudden spikes in the application or else these are all comes under the main monitoring and maintenance aspect. So here the most crucial part here is procuring the equipment. Okay, so creating the servers is very tough job for us. With the help of infrastructure as a code, what we can do here is we can automate that. So how we are going to automate that, I will tell you. And then we will be going into the CI/CD process. What does the CI/CD process mean? Continuous integration and continuous deployment or development. So now what is going to happen over here? So whenever the developer, so I said, the application is developed by the developer. Whenever the developer develops the application and push it into the related repositories, either it might be GitHub, GitLab, or else it might be Bitbucket. So whatever the repositories that are available, so he pushes the code into the repository. Once the code is pushed, automatically the code has to be built and it has to give us the application very fast. So this DevOps will be helpful for that with the CI/CD pipelining tools like Jenkins, GitHub Actions, GitLab Runners. So like that, there are so many different types of CI/CD pipelines tools are available. So Jenkins is one of the availability tool. And finally, so applications are built to leverage the cloud infrastructure scalability. So we will be connecting it with the cloud native. So now if you see the entire process here, so we will be working with the cloud environment. Okay, so we are not going to work with an on-premises environment. There are two environments. One is the on-premises environment. What is meant by on-premises environment means there is an IT company. For that IT company, if there is a server room or else a data center is there, then that is called as an on-premises. If the IT company is not relying on the physical infrastructure, rather than it is depending on the cloud infrastructure, like having the GCP, AWS, or Azure accounts, inside that accounts, if they are creating their resources, then that is called as a cloud native. So with the help of cloud, what we can do here is instantly we can roll out the servers, instantly we can destroy the servers, instantly we can scale up the servers and scale down the servers. These are all can be done very fastly. And when we include the Terraform infrastructure as a code, automatically what is going to happen? Your manual creating the resources won't be there. If you see here, manual management. Manual server management is often slow and error prone, leading to the inconsistency and deployment challenges that traditional approach can be hinder productivity and increase the risk of configuration drift. So what is the meaning of this means? When you create the resources manually, it will be slow. First of all, we need to log into the AWS environment, and then we have to select the VPC service, and we have to create a VPC, subnets, routing tables, internet gateway, and then security groups, and we have to deploy the EC2 instance. When we are deploying the EC2 instance, we need to select the AMI key pair and instance type, and then we have to select the subnet, and then we have to select the security group, and we have to provide the user data. So it is going to take a lots of time to deploy the server. So rather than that, what we can do here is, if that is one time only once it is a time taking process. If we have an infrastructure as a code, if we create the resources through the code, for writing the code, it is going to take time. But the similar code you can use for the multiple infrastructures. Okay, for example, there is an X company is there. For the X company, you can use the same code. For the Y company also, you can use the same code by changing the values. So it is going to save you a lots of time, and that can be done by the infrastructure as a code. That is nothing but your Terraform. So this infrastructure as a code is having like for multiple, what I can say, for multiple cloud environments, we are having uh, multiple types of tools are there. So for example, if I take AWS, it is cloud formation, and for Azure it is ARM templates, and for GCP also, I think for GCP also Google Cloud resource management or else templates are there. If I am not wrong, I'm not very familiar with GCP. For GCP also there is an infrastructure development tool. And I don't want all these tools. Okay, so this cloud formation is only for AWS environment. For Azure, it is ARM templates. So for each and yeah, deployment manager the same. So cloud deployment manager is there, or Google deployment manager, or Google Cloud deployment manager is there. So for GCP, there is a separate deployment manager that are related to those clouds only. But my requirement is that I want to have a single tool which can cover the three environments. Okay, for example, I need to have a tool that will create the resources in Azure, that can create the resources in AWS, that can create the resources in GCP. Not only that, this tool can create the resources in the VMware also, in the on-premises environment also. And that tool is called as your Terraform tool. So the Terraform is a very, very crucial tool for developing the infrastructure. It's a third-party application developed by HashiCorp, but it is it is it has been very, very important and crucial tool for developing the infrastructure. So now, depending on this Terraform, what we are going to do. So what will be there inside the Terraform? In Terraform, we will have the Terraform basics, Terraform functions, and Terraform modules. Inside the functions, again, we will have the conditional expressions. Expressions will be there. So these are all the things that we are going to discuss. And then we will have the Terraform enterprise and Terraform multi-provider environment. Like that, we are going to discuss a lot of things. So what are the benefits of IAC? IAC in the sense infrastructure as a code. So infrastructure as a code offers speed, consistency, and version control. It automates the deployment and allowing the teams to quickly provision the resources while reducing the human errors through clear and declarative configurations. Within short span of time, we can create the resources. We can create the entire infrastructure. We don't need to worry about how it is going to be created. Very, very fastly it is going to be created, and we need to understand the language called as HCL language. There is a language for this Terraform to create. That language is HCL language. Okay. And the next one is, so Terraform simplifies the resource management by enabling the declarative configuration. Declarative configuration in the sense writing the code. Okay, writing the code in the HCL language is a declarative configuration across the platforms like AWS, Azure, and GCP, ensuring the consistent and reliable infrastructure development. So that is about your uh, Terraform. So if you see here, this is how the code will be looking like. So you need, if we want to create a VPC, so AWS underscore VPC. So we are going to create the VPC CIDR blocks. And if I want to create the subnets, so how we can create the subnets, everything will be defined in this format. So this is not a JSON format. This is the HCL format, HashiCorp language format, that you will understand when we go into the Terraform. And finally, let us go with the Docker. So I hope you understand why we need to have the Terraform. So if I say you in the beginning, so whenever we want to have a server, it is going to take at least 1 month to procure the server and for installing the applications onto the server. To overcome this problem, what we are going to do, we are going to use the cloud environment and we will be using the Terraform as a tool to complete the entire process. So by using the Terraform, what we can do here is within short span of time, we can create the entire infrastructure. Okay. So do you understand what is Terraform? Any questions here? I just gave you a basic glimpse of Terraform, but actually we will be diving into the main concept from tomorrow onwards. Any questions of Terraform?
Hello, Chaitanya, good morning.
Good morning.
Actually, in our content, I saw like Docker, Kubernetes, Jenkins, and Terraform, but in slide, I'm not seeing Jenkins here. So that's, can you just,
Jenkins is not there, no?
no, in that course content, it is there.
I don't see that, but whatever the poster that is released, that is only for the Terraform.
Yeah, if you see your the details, like what DURGASOFT has shared, in that Jenkins also there.
Okay, no problem. We'll talk about that later. Okay, fine. Okay. So that's fine. We'll discuss about the Jenkins also. No worries. Okay. At the end of the complete this Terraform, Docker, and Kubernetes, we will discuss about the Jenkins. What is it? So it's a CI/CD pipelining only, no? No worries. Okay. So Terraform is an open source, it's a free. So you can simply have your Terraform installed on your computer very simply. I will tell you in the next session. So any another questions? Okay. Anyways, I just saw that. Fine, no problem. Any questions? Related to Terraform, don't include the Jenkins into this, but anyways, related to Terraform, any questions? Okay. How deep we are going to go with that, I will tell you. But see, that we will discuss in the end of the session. But right now, technically, I am asking any questions. Deeper, what are the syllabus that I will tell you? Okay. Now let us discuss about the Docker. So now we have procured the equipment. We have got the infrastructure. Now, once we got the infrastructure, then what we have to do? We have to run the application. So if I have to run the application, let us discuss about this in a very, very simpler manner. For example, in our IT industry, so what we are going to do here is, okay, whatever you want to ask me, you can ask me at the end of the session, guys. Okay, Terraform and OpenShift are completely different. Terraform is infrastructure as a code, and the OpenShift is a containerization platform, orchestration platform, like Kubernetes. So both are not same. Okay. So OpenShift is for handling the containers, while Terraform will be the underlying infrastructure. So how they can shift from Terraform to OpenShift. Okay. Anyways, coming back to the point here. So whenever we are working with the application, so the developer, whoever the developer is there, so this developer will have a laptop and he will develop the application inside that. Okay. So inside his laptop, he is going to develop the application. So when he develops the application, he will write the code according to his environment. He is going to write the code according to the environment. So when he writes the code according to the environment, he right now the developer will not keep in mind that this application has to be deployed on an server and it has to run. So that knowledge or else that thought will not be there. Actually, he will think that of course we have to run inside the server, but depending on the environment which he or she is having, they are going to develop the application in that. So once the application is developed, okay, once the application is developed, when this application goes to the server, there comes the problem. Why? Because the environmental changes will be there. Okay, so because of the environmental changes, the application which he created in his laptop will not work fine on the server. So if I have to tell you in a simpler manner, for example, one of you got an promotion in your job, and you want to give a party. So you asked all your employees to attend to that party, or also all your colleagues to attend to that party. So everyone are coming. So you want to cook some food. Okay, all your friends are gathering together. So you want to cook some food. So now what you have done, you prepared a very delicious dish in your kitchen. Okay, in your kitchen you have prepared it. So now once you have prepared that, everyone liked the dish and everyone is saying it is fantastic. And some of your friends ask you for a recipe. So can you please give me the recipe of this particular food item for this particular dish? So you will provide the recipe for that. So when you provide the recipe, if your friends are trying to cook the same food in their home, whether it is going to come as it is or else it is going to be a little bit different. So right now, if you see in YouTube videos, we will be watching so many number of cooking videos. I don't know whether anyone is watching or not, but I watch because I'm a foodie. If I want to eat something, definitely I will go through some YouTube content. I will check out that, and I will take the recipe and I will try to cook that food. But if whatever the food that is cooked in that YouTube channel, whether the same texture or else same taste will come, or also, I mean, of course, from the videos you cannot eat. But what is my question here is, if that particular employee, or else if you cook the same food and if your friend is trying to cook the same food, whether both are going to be the same or else whether there will be any changes. Hmm. Anyone tell me about this? This is a general question. It is not a technical question. You can answer it. If you understand the question, you can answer that. Okay. Anyone?
It will be changed because both are different platform.
Not about the platform. I'm talking about the food. I'm not talking about the application. Don't come to the technicalities here. I'm just asking about it.
Non technicality. Yeah.
Yeah.
What we believe it will be not up to that one. It may change.
Up to the mark you will not have. It will be a little bit changes will be there. The
Yes,
taste
yes.
might be changed. The texture might be changed. Why? Because the process is changed. Okay, there might be, so in your environment you will be creating according to the ingredients whatever you are having, and your environment might be a little bit different. He might be cooked that food on a medium to slim fire. You will be cooking on a high fire. So depending on that, the texture might be changed. In the same manner, for example, you created an application in your computer. So in your computer, you are creating that, or else in your workstation, you are creating that application. Whenever you are creating that application in your computer or workstation, the application dependencies will be in your hands. For example, I am creating a Java application. It requires a particular updated tool it requires. So now what you will do, you will download that plugin and install that in your application. So if you are running like Maven application Java with including this Spring Boot application you are developing, so it requires any plugin, you will download it and install it. So everything you will install in your computer, it won't happen anything. But when you transfer this application to the server, inside the server already some applications will be running. So the older applications will be running, some applications on a different application platform will be running. So when these applications are running, whenever you are installing a newly updated application, so the Java one, for example, in this server already one application is running, and that application is running with the lower level plugins and lower level dependencies. And you are creating a new application which is requiring the high level dependencies and high level plugins. Then there will be a conflict. So what is the conflict? If you install the newer application, the old application will be not properly running. If you are going with the older application, the newer application will not run in your server environment. So to overcome this problem, what I have to do? So simply, when we coming back to the same example, so when my friend says that it's came beautifully recipe, I will say that you don't need a recipe. What I will do here is I will cook the entire food and I will pack it in a container. Container in the sense the box, okay, the lunch box or else anything, and I will give it to you. So don't worry about the food and all the things. So you can enjoy your food with your family. So when I say that no, so now what happens? The application, I mean, the recipe will be included into that, and as well as the food is also given to the user and in a container box. In the same manner, whenever this application is getting created, now what I will do here is I will do the containerization. I am going to do the containerization. I am going to pack the entire application and its dependencies inside a container, and I can move that container from one environment to the another environment where the containers will be happily running. So there won't be any dependency issues, there won't be any application running issues, and everything will be quite common, quite clearly it will be running. So this is the process of your application configuration. So with the help of Docker, what we can do here is Docker is not a container. Docker is a containerization platform. Container is different, Docker is different. So Docker is a containerization platform where you can run the multiple environments of the containers with its application and its application dependencies. So inside the container, what you will have here is you will have the application and its dependencies. For example, I want to create an Java application. For Java application, I need to have the Java runtime installed inside the infrastructure. So inside the container, what we are going to do, we will be installing the infrastructure. We will be installing that runtime, Java runtime. On top of that, what is my requirement? For example, that application is a Spring Boot application. For that, I need to install the what I can say. I need to install the Maven to build that application. Maven is my requirement. So like that, what is happening for any application to run, we need to have the dependencies. So depending on that, inside the container, we will have the application and its dependencies. So we will pack those things into a container and we can shift it from the computer to the server, and from development environment to the production environment, everything will be easily happening. So this is about your Docker. So when we talk about the Docker, so what we are going to talk, Docker enables the lightweight containerization for seamless deployments. And what will be there inside the Docker? So this is what Docker consisting of, or else Docker workflows. The developer will write the code and define the application requirement in the Docker file. So we are going to create a Docker file. It is also a declarative format of creating the image. Okay, so the developers will write the code. So where on which platform, depending on the client and depending on how knowledgeable is the developer, he might be developing the application in the Python, or else he might be developing in Java, he might be developing in .NET, Ruby, Golang. There are so many backend languages are available. When you come to the front end, there will be HTML, CSS, JavaScript, and then React JS, depending on the knowledgeable, or else depending on the team efficiency or else team knowledge, you can select an application tool and you can develop your application. So the developer will develop the code and define the application requirements in the Docker file. So every developer should have a knowledge about how to write the Docker file, so that the DevOps engineer doesn't need to have this particular, or like whether he has to select what is the dependency. Every time he has to sit with the developer. Why he has to sit with the developer? He should know which dependencies of Java the application will be running. So right now, if you see, some companies are still using Java 8. Some companies are still using Java 17. Some companies are still using Java. I mean, they
Advanced.
upgraded to Java 21. 21, 25 is the latest Java version that is available. So the developer has to sit with the DevOps engineer has to sit with the developer, and he has to note down what are the Java versions, what are the packages that he has to install, everything. Rather than that, if developer himself knows that or how to write the Docker file, then that will be very handy. So first of all, the code has to be written, and finally the Docker file has to be created. Once the Docker file is created, the code is built into a portable Docker image that encapsulates the application. So we are going to convert the Docker file into an image format. So images are nothing but the templates to run your containers. For example, if I want to install an operating system inside the computer, what you are going to do? First, you will put a pen drive. Inside that, you will have your Windows operating system or Linux operating system. Step-by-step process will be there. Country you have to select, language you have to select, and then you have to select the hard disk, and then you have to start installing, and it will install all the unwanted applications are also going to be installed. So these are all the things that is going to happen. But when you come to the images, images are lightweight. Docker, especially the Docker images, are lightweight images or else lightweight applications which will include the operating system binaries and as well as application and its dependencies. So inside when you are using the image, you don't need to install the operating system. The image itself will have the operating system binaries. It is not going to have the entire operating system, and all the unwanted applications is not going to be there. You will have only wanted binaries. For example, if you take the Ubuntu image, okay, so the Ubuntu Docker image is of only 70 MB. If you take Python image, it is also 70 MB. Depending on the image that you are taking, the size of the application size will be the same. But when you convert that into a Docker image, what is a Docker image? Docker image is a code built into it with what I can say, with the encapsulation of the application, which means that the dependencies will be there inside the image and as well as the application will be there. So how we are going to create that we will see when we go to the Docker. And finally, container. What is a container? Then the Docker image is deployed as a running container in any environment. You can use the image to deploy the container in any environment. Either you are creating in Windows operating system, the container will be running. If you are running in the Linux operating system, the container will be running. Containers are what I can say operating system independent. Okay, so why they are operating system independent, that we will see in the upcoming sessions. So this is the Docker flow. First of all, you need to write the code and convert the code into an image and transform that into the container. Okay, now we have the containers on board. Now what you need to understand here is Kubernetes overview. So did anybody is working in Mumbai? Why? Because I worked there for 2 years. I'm just asking. Anybody from Mumbai? Most of the North people knows about this particular term called as Dabbawala. Anybody knows about that?
Yes.
What is that? What this Dabbawala will do?
Actually, there's
Hmm.
what I can say is
They are going to serve. They are going to
serve, yes,
collect
the
the lunch
container,
boxes from
lunch
each and
boxes.
every from each and every home or also the connected homes, and they will serve it to the employees. That is what
Yes.
the functionality of this Dabbawala. Mostly in North, I see majority number of these people. Okay, now when we come to the orchestration, let me take the same thing. So each and every home is like an environment. From each and every home, one container is coming. Okay, one container in the sense, one type of lunchbox is coming. So every lunchbox is having a particular dish. It will be having certain food. Now, what this Dabbawala will do, what this man will do here is he will gather every lunchbox from each and every home. He will put it neatly inside a particular tray, and he will come to the office and give it to the employees, which means that the work of this particular person is to collect that, to manage that. Especially management is very important, to manage that and to provide the correct lunchbox to the correct person. So in the same manner, what Kubernetes is going to do here is Kubernetes is going to manage the entire containers, whatever the containers that we are created on the containerization platform. Kubernetes is helpful for managing that and for scalability of the application. Scalability in the sense, for example, I have a container, and inside the container, I am running an application. suddenly the load on the application is increased depending on maybe it might be sometimes what happens, the CPU consumption will be increased, RAM consumption will be increased because of the bugs or else because of the external load also. External load in the sense, for example, if I gave an offer, so flat 50% prices are reduced on this travel agency. So if I say that the red bus is giving flat 50%, not up to 50%, flat 50% off on the bus ticket bookings. Now, what happens? The people who are not interested in traveling also, they will start booking the tickets. And I say that this offer is only for this particular limited period. At that particular point of time, what happens? The application is running inside the container. Suddenly, the load on the container will be increasing. When the load on the container is increased, automatically single container cannot withstand the load. For example, if you go to a mobile shop, only single salesman is there. Outside the mobile shop, the owner has displayed the board, purchase any mobile, we will give flat 50% off. So now the iPhone 16 is coming at a cost of 60,000. It is going to come at 30,000 only. Majority people will go and purchase it. Okay, so single salesperson is not sufficient for that particular bonanza offers at that offer time. Now the now the owner has to hire the salesperson. So he will hire a few more salespersons to manage the entire crowd. In the same manner, single container is not sufficient for managing the crowd if there is a huge, to manage the entire requests that are coming from the client. To manage that automatically, a few more containers should be deployed. How that can be done? So Docker cannot do that. Docker doesn't have this auto scaling compatibilities and all the things. So Docker will have only the configuration of creating the containers, but Kubernetes will have that. Kubernetes is having a feature of auto scaling, and as well as Kubernetes will look after the containers. If there is any container is killed, automatically it is going to create one more container. So we don't need to create that. So that management will be done. And the Kubernetes will expose the application for the external users depending on the services, ingress controller, and there will be, we can decide that this container or this application can use only this much amount of CPU and this much amount of RAM in the Kubernetes. So how this Kubernetes will be working means Kubernetes will be working with the concept of manifest files. Manifest files are very crucial in the Kubernetes. We need to learn about that. Anyways, we will be learning about that concept in the upcoming session. So now what is this Kubernetes? So if you see here, Kubernetes components, what are the different components? Pods, deployment, services, nodes, ingress controller, and additional details, whatever you want to learn. So we will be discussing about these pods. Pods are the smallest deployment units in the Kubernetes. Inside the pods, you will have the containers. When we go into the Kubernetes, we will talk only with the pods only. And then deployments. So I said, whenever a container is deleted, automatically a new container will be created. That can be happened with the help of the deployment. Nodes means servers. Nodes are the worker machines in the Kubernetes. When pods where pods run, and they can be virtual or physical, playing a crucial role in the resource allocation. So nodes will be there. And finally, you will have the services which are helpful for to expose the application for the end customers. So this is about the Kubernetes and how they will work together, whatever we have discussed over here. Terraform for provisioning the infrastructure, so for creating the infrastructure, and Docker is for packing the application, and Kubernetes is maintaining the containerization, to maintain the containerization. When we come to the Jenkins, so Jenkins is a tool which will be helpful for connecting all these three processes, and it will generate the end application for the customer. So Terraform will provision the infrastructure. So how that infrastructure will be? So in Jenkins, we are going to write the stages. So we will discuss about the Jenkins at the end. Not today, but at the end of the sessions or at the end of the course, when we are provisioning the Terraform. So when we want to create the infrastructure in the Terraform, we will write a Jenkins stage. When we are creating the Docker in that provisioning, then we will be writing the Docker code, and then we will be going with the Kubernetes deployment. So I will do one thing. When we are discussing about the Terraform, before we discuss about the Terraform, what I will do here is I will try to create a Jenkins server. And I will initial stages, I will discuss about the Jenkins. I'm not going to talk about entire CI/CD platform here. we'll be talking about the basic concepts of Jenkins. What is Jenkins? What is Jenkins master node, slave node, and then how we can take the backup of the Jenkins and everything we'll discuss over there. And then what we will do here is we will try to create the CI/CD pipelining tool. So when we are doing the CI/CD pipeline tool, what I will do here is when we complete the Terraform, I will include this Terraform into that Jenkins pipeline. And then we will include once we have completed the Docker, we will include the Docker into the Jenkins file. Once we have completed the Kubernetes, I will include the Kubernetes into the Jenkins file. So that what will happen? So you will get a clarity that, okay, Jenkins is managing the complete infrastructure. Jenkins is managing the infrastructure and the containerization. Jenkins is managing the infrastructure, containerization, and orchestration. So with the at the end of the course, you will know that how to integrate all these processes into the CI/CD pipelining and how to do the automation of that particular pipeline. You will get a clarity. And in Jenkins, what we will be discussing means we will be discussing about creating the Jenkins configuration and then taking the backup of Jenkins and how primary and standby Jenkins nodes will be there. When the primary is done, how standby will be working, and these concepts will be there. Later, we will be discussing about the Jenkins master slave architecture, and then we will be discussing about the pipelines. So, what is meant by declarative pipeline and what is meant by scripted pipeline. These are the concepts that we will be discussing. And then finally, we will go into the writing of pipelines and how we can write the pipelines and how we can use the shared variables. So these are shared libraries will be there. So how we can use that shared libraries. These are the concepts that we are going to work with the Jenkins. And once it is completed, up to shared libraries is completed, then we will go into the Terraform and we will discuss about the Terraform concepts related to Terraform basics, Terraform functions, Terraform modules, Terraform enterprise, and Terraform multi-provider environment. And HashiCorp Vault also we will be discussing for securing the whatever the what I can say. If you include any keys, okay, like PEM files or else any keys, how to secure those keys in the HashiCorp Vault, we will discuss about that. And once the Terraform is completed, we will include the Terraform into the Jenkins. And then we will go ahead into the concept of Docker. In Docker, what we will be discussing here is I'm not going to give you the entire syllabus as you know the syllabus. I'm just telling you the syllabus content over here. In Docker, we will be discussing about the Docker basics, Docker architecture, and then Docker container lifecycle. And we will be discussing about Docker images, Docker volumes, Docker networking, and finally Docker Compose. And at the end, we will discuss about the Docker Swarm. And after the Docker is completed, we will include the Docker into the Jenkins file. And then we will come to the Kubernetes. Kubernetes is having huge number of content. Lots of content is there which we have to cover. So starting from Kubernetes, microservices architecture, Kubernetes architecture, and then we have to discuss about the Kubernetes creation with the help of KubeADM, KOps. KubeADM is a tool which will be helpful for creating the Kubernetes cluster. Here we are not going to discuss on Minikube. Those who are expecting that we will be working with the Minikube, so I'm not going to tell about the Minikube. We will be working on the production grade only, on the production environment or else on the company environment, how you are going to work. Depending on that, we will be discussing about the concepts related to Kubernetes cluster creation with KubeADM, Kubernetes cluster with KOps, and then we will be discussing about the workload components like pods, deployments, replica sets, stateful sets, daemon sets, and then we will be discussing about the services like cluster IP, node port, load balancer, and external name and headless services, and then we will discuss about the ingress controller, and then we'll be having the concept of sidecar containers, and then probes will be there, and we'll have a clear cut understanding about the namespaces, resource quotas, and then we'll have an RBAC, role based access control, and service accounts we'll discuss. Like that, there are so storage is there, Helm charts is there, GitOps is there. When we completed the Kubernetes, we are going to integrate this Kubernetes into the Jenkins pipeline. So with the help of this entire content, we are going to close the batch within 30 days. So the expected time to complete the batch is by January 1st, or else by December 31st, we need to complete the topic. Okay, so every day at 7 o'clock, you will have the session. Okay, 7 a.m. you will have the session, and What else? What else? You will get the videos and documentation. So for Terraform, you will get the GitHub access. Not the GitHub access, you will get the GitHub repository for the code configurations. And for the Docker and Kubernetes, you are going to get the documentation. So don't skip the classes for Terraform. At least attend the classes for Terraform. I know that so many people are having lots of work, but what I want to share you here is don't skip the classes for Terraform. Why? Because you are going to get the URL. So those URLs are required for you when you want to download the code. So that is my request. And the next one is what else I have missed? That's it. So if you have any further questions, you can ask me now. Last 5 minutes. Of course, the time has been completed. Any which ways.
Sir,
Any questions
78, sir. Classes 78, sir. Classes.
7 to 8 or 8:30.
Oh, 8:30.
Most probably it will be. I will try to complete the session by 8:15 a.m. But if the concept is a little bit high, or depending on the concept. For example, today I am talking about the Kubernetes storage.
Okay,
Definitely, I
sir.
need to take 1.5 hour of session. Okay. And by the way, the sessions will be, you will have everyday sessions, or else I will call it as weekdays only. But in this 4 weeks, we are going to take at least 2 weekends also. Okay. Which means that on Saturday and Sunday also, you will have the sessions at the last 2 weeks. 2 weeks, you will have the continuous sessions. Okay.
Okay, sir.
Terraform will take 7 days to complete. Most probably, yeah, 7 days. If I have to give you an daily format, Terraform will be taking 5 to 7 days, and Docker will take some 5 to 7 days. It is also, and Kubernetes will take at least 20 days. Kubernetes itself will take 20 days. Why? Because the area of concept will be very high. Okay, I don't know outside how they are talking, so how they are taking within a small time, but I don't want you to be affecting with having a minimal knowledge on the concepts. I want to have you a clear-cut understanding about this. Okay,
Argo CD will be covered, sir. Argo CD.
that is what GitOps.
GitHubs. Okay.
GitOps Argo CD will be covered,
Mm-hmm.
and yeah, service mesh we will cover, and Prometheus and Grafana, including the Kubernetes concepts. Okay. So Prometheus, Grafana, and ELK stack we will discuss in the logging process will be there. We will be discussing about that. Elastic Cache. We will discuss about lot of other things also. Elastic Cache is, anyways, we will be discussing about all the logging concepts, and we will be discussing about the monitoring tools like Prometheus and Grafana with the Kubernetes. I don't want to give you a false statements, but yes, STO service mesh will be covered.
Hello.
Yes.
Will you be deploying, multiple services and, see MTLS, how they authenticate, etc.?
That is what I said. MTLS, you will be included with the STO service mesh only, no?
Okay. Yes, yes. Yeah, so,
Then,
okay.
see,
Sir,
projects.
AWS.
Yeah, go on. AWS is the primary requirement, guys. Sorry to stop you. AWS is the basic requirements. Why? Because we are going to deploy the complete infrastructure, and as well
Okay,
as
sir.
we will be working with AWS only. Okay. So GCP also, sir, I have a very hands-on knowledge on GCP. Then how I can work with I am having hands-on knowledge on Azure. So simple. The provider will changes, and rest of the configuration will be. So if I am telling you Terraform, there I will explain you what you have to do with it. Okay. Yeah, AWS is. We will be working with AWS only. And Sai, any projects? Okay, very good question. So, for example, if I purchase a mobile and give it to you, okay. If I purchase a mobile, you want a mobile. If I purchase a mobile and give it to you, what are the specifications that you want? You will have entire specification in that mobile, okay, and give it to you. Will you be able to learn how to integrate everything? Or else, if I discuss about the entire concept of mobile manufacturing, okay, then from where the goods will be there, from where you have to integrate, how you have to integrate everything, then that will be helpful for you. So here we will be having the entire core concepts. Okay. So when you go for an interview in DevOps also, okay, when you are going for the uh, what I can say, whenever you are going for an interview for the DevOps, they are not going to ask you about the which projects you have worked for. Okay. They will be asking you what are the recent tools that you have worked on. So if you say Terraform, they will ask you the questions on Terraform. So for the developers, they will be asking what are the have you created any projects? So in which projects you have worked? Can you explain the functionality of that project? So that they are going to ask you. But for the DevOps engineer, what an interviewer will ask you here is what are the tools that you have worked with? What is the latest configuration that you have done? So if I talk about the project, inside the project, I won't be using the necessary tools. Okay, I will be using only the necessary tools, and rest of the tools will be skipped on that. So you will be having the complete knowledge on the each and every tool, okay, each and every concept, so that you can apply the tools on any project. Okay, if you take a Java project, you can create a Docker file for Java project. If you take a Python project, you can create the Python application. If you take any another project, so depending on the core concepts are important rather than knowing on a fundamental basis of understanding the project. So I recommend everyone to understand the core. On top of that, you can build everything. For example, if you know how the foundation will be laid on that, you can create the foundation. On top of that, either you can build a house or else apartment or else a theater or else a multiplex or else a shopping mall. Anything can be created. So it is my requirement that you need to have a clear cut knowledge on the application code. The whatever the topics that I have said. So later on that, if you really want to know about that, so I will give you a project on that. It is not a very big deal to provide a project. I will provide a project on that, how we have integrated all these concepts at the end. It's a simple 1 day topic. But it is my requirement. I will be more happy if you learn the core concepts. Okay. Right. Anything else?
Yes. Sir, when is your DevOps with AWS 9:30 batch is going to be started, sir? 9:30.
That is not right. We will have it happening. First of all,
So,
let us go with this Terraform and Docker batch. So
okay,
why?
sir.
Because that will take some time. Okay, so we're still having an ambiguity in that. We don't know when it is going to be started. They have given some date, but I'm not very
Mm-hmm.
sure about that. Okay, so yeah,
Okay, sir.
I will tell you.
No, sir, I'm looking for a AWS batch, sir. When is your AWS batch is going to
AWS batch is about to
start?
start. Only AWS we are planning. I will let you know when this only AWS batch we are planning. I will let you know within another 10 days it will start.
Okay, sir. Timing, sir?
Okay.
Timing. What is the timing?
Timing will be around 8:30 a.m. to 9:30 a.m. most probably.
Oh, okay, sir.
Right? Yeah.
Okay, sir. Thank you, sir. Yeah.
Right then. Any another questions, guys?
See, I am having 14 years of experience in backup and storage domain. Okay, so after
Mhm.
completion of this course, so how
Mhm.
will I, build my resume and I show the interview that I worked on real-time environment, real-time projects. At least for I'm planning to put some 5 years or 6 years experience in my resume. So
Mhm.
how can I do that? Can I do that? Is it possible?
Okay, I just want to tell you one thing. 5, 6 years, I won't say that, but you can put up to 3 to 4 years of experience.
Three
See,
to four years.
whatever the technical aspects that we are going to cover, you can put 3 to 4 years. Why? Because see, if you say 5 to 6 years means you will be more hands-on experience. You will be expertised on that particular concepts, right? So suddenly, if they ask you a very in-depth question, then that will be a little bit difficult to answer for you. You can put. I don't say that you cannot put 5, 6 years of experience. I don't know what is your financial status. Depending on that, also you can put some 5 to 6 years of experience to cover the entire gap. But the point is, whatever the course that we are going to cover here, you can put up to 3 to 4 years of experience. That is what I can say. That level of knowledge you are going to get. Okay.
Okay. Thank you.
Right. Senior level, yeah, you can put up to the senior level. And yeah, we are going to complete the entire course that we have discussed in the syllabus content, whatever that the syllabus content which we have covered, we are going to cover that. Don't worry. Right then. So here I will stop my session. Any which ways, I have another session at 8:30. So we'll meet on tomorrow's session and discuss about lots of topic related to Jenkins. We'll start with the Jenkins. Okay. So in these 2 days or 3 days of like tomorrow, tomorrow and day after tomorrow, you will have the demos and we'll work on the Jenkins and understanding the Jenkins configuration, working with the Jenkins and everything. Most probably, I will try to cover at least we need to start the technical concepts. So in the demos itself, I will try to cover the Jenkins, basic Jenkins concepts, and later we'll discuss about the pipelining tool once we have completed the demos. So we will go very slowly. We will be working with the what I can say. I have my virtualization cloud in my home environment. I will be using that if possible, or else I will be going with the AWS environment for deploying the servers. And for Terraform, Docker, and Kubernetes, we will be working with the AWS environment. Okay. So have a nice day, and we'll meet in the next session, guys. Bye.